Okay, next video we'll have a look at. Look at that. We're going to look at on repeated linear, right? From partial fractions on repeated linear. If you can see here, the denominator of this fraction here shows that x plus 3 cubed. So this means it is in terms of repeated. So it's repeated itself, which is the denominator is called repeated linear, which is depends on the denominator, right? So first you have to put that in the form of partial fractions. Remember from our first introduction video, we're gonna have to decompose that into partial fractions. So there will be the partial fraction will be a over x plus 3 plus b over, there is one factor there, x plus 3 squared plus c over x plus 3 cubed. Yeah, so that is our decomposition or the form of partial fractions from this fraction. All right, so first things first, you have to solve this fraction. When you have an addition and fraction, what should you do? You should find the denominator. What are the denominator for this? It will be x plus 3 cubed, yeah, because everything can be divided. This one can divide this can be divided by this, right? X plus 3 divided by this, you will get a multiplied by x plus 3 squared, right? This one divided by this, the left out is squared, plus b, this one divided by this, you will get with only 1, which is x plus 3, and plus this one divided by this, you can, there's 1, which is from c, right? So you have this form, which is in the form of a x plus 3 squared plus b x plus 3 plus c divided by x plus 3 cubed, which is the same as this one, yeah, which is 3x squared plus x plus 15 divided by plus 3, right? So you can actually take out this area because this section on the top here is equivalent to this section, so we can take this section off, right? Or if you multiply that, it becomes divide, and then it will come out with this one. Okay, so it's 3x squared plus 16 plus 5. So what should you do first? You have to solve the find or put the value of this one when x equal to -3, right? So first thing first, you need to find the value of, you can find any value of the a, b, and c here. So when x equal to -3, then you put the value of x inside of this. So 3 times -3, I'm going to put that into different color. 16 times plus 5 is equivalent to a plus 3 squared plus b plus 3 plus c. So the one that we left out there will be -3, this one is -3, this one is negative. So we can solve this equation, which will be 3 times -3, which is 3 times 9, which is 27, plus, or this will become negative, 48 plus, not 5, this is not 15, it is 15, is equivalent to a times this one is 0, which is 0, plus b, this is 0, 0 plus c. So which is negative, if you solve it, become -c is equal to c. So c is equal to -6. Now we need to find the value of a and b. So how can you find the value of a? If you look at this equation here, let's say this is equation 1, right? If you look at these equations, we can actually simplify because we cannot put any more values, because when x equal to -3, yeah, there is no more values that you can put. X is only one factor here. x only equal to 10. So how can we find the value of a, b and c? So we can use this equation 1 then, which is, you see here, let's put them back here. 3x squared plus 16x plus 15 is equivalent to ax plus 3 squared plus bx plus 3 plus c, right? So we have that. You just write down this again, right? So you can actually decompose it, or you can actually expand this, yeah? You can actually expand this, it will become, if you expand this expression here, it will become 3x squared plus 16x plus 15 is equivalent to a times x plus 3 x plus 3x plus 3, which is x squared plus 3x plus 3x plus 9, which is x squared plus 6x plus 9, right? You have that x squared plus 6x plus 9, right? So you have, this one is x squared plus 6x plus 9 plus bx plus 3b, right? Plus 9 plus c. You can still expand this. Ax squared plus 6ax plus 9a plus bx plus 3b plus c equivalent to 3x squared plus 16x plus 15. Now, when we expand this, we have to know what we call as the equate. We can equate this equation. As you know that, you can still look at the term x squared, this is x squared. This is x, this is x, this is x, yeah? So we know that a here is equivalent to this. 3x squared is equal to ax squared. So a here means that a is equal to 3. Yeah, you know that 3x squared is equal to ax squared. So there is no more x squared term, so meaning that 3x squared, 3 here is equal to a. And then we have x term. We have another term which is 6x. 6x here is one x term, this is another x term, right? So 6x is actually equal to this, right? So we can say that 6x is equal to 6ax plus bx, right? So when you put that as 6ax, you can remove x. 6 is equal to, if you remove x, 6 is equal to 6 a plus b, right? So you know that a is equal to 3, a equal to 3, so 6 is equal to 6 times 3 plus b, right? So equal to 18 plus b, so 6, so b equal to 6 minus 18, which is, what is 6 minus 18? Minus, no, it should be 6, yeah, b is equal to 16. 16, oh no, this is 16, sorry, this is 16, this is 16. So 16 minus 18, which is negative 2 equal to b. So you have the value of a and the value of b, right? So when we put them back in our equations, you have 3x squared plus 16x plus 15 over x plus 3 cubed is equivalent to, what is a? A is 3 over x plus 3 plus b. What is b? So negative 2 over x plus 3 squared, and then c is negative 6 over x plus 3 cube, right? So that will be your answer for this partial fraction. Okay, so have a look at them and then try and do that one by one again. There is some different problem as well, which is regarding the repeated linear factor. Right? Thank you very much.